Alrighty, thank you all for coming. Today's Lunch and Learn is going to be about deployment with AWS. So I'll be using EC2 with an elastic load balancer and S3 with Cloudfront. And really this is a scalable deployment, meaning that it can go from 10 users to 1 million, all using Amazon Web Services infrastructure. And I'll show you all the parts and pieces involved in that and how we get that going. Quick stretch, everybody reach into the sky. Ooh. Alrighty. Kyle, can you read the first objective?
Define AWS, EC2, S3, Elastic Load Balancer, and Cloudfront.
Yes. And Kim, can you read the next objective?
Describe the role each plays in a scalable deployment.
Right, so I think really a lot that you guys can take away from this is just what this all means and how they all fit together. And then I will go into a demo and kind of show you some of the deployments I have and potentially make a new one. I don't know if I'll have enough time, but I think really if you can walk away from this knowing what all these things are, I would call that a win. And yeah, so this is the extra stuff I'll eventually get to. And really one of the reasons I even figured out to use this type of deployment was because Amazon actually gives you free SSL certificates. And so I'm able to use a free SSL certificate in front of a load balancer that's pointing at my EC2 instance and in front of CloudFront that's pointing at S3. So I'll show how to do that. And then potentially walk through doing one of those deployments. So first, AWS stands for Amazon Web Services. It is infrastructure as a service. And all these other things that I'm going to be talking about, S3, EC2, load balancer, they are all under the AWS umbrella, meaning they're a service from Amazon. So the first thing that I'll be using is EC2. So EC2 stands for Elastic Compute Cloud, and it's essentially just virtual machines. If you're used to any other infrastructure as a service, EC2 is virtual machine. I can say spin up a new Linux machine, and I now have a Linux machine running in the cloud. You can spin up Windows machines, there's Amazon Linux, but the idea is it's not a physical rack computer, rack server. It is just a virtual machine that is running on some other physical infrastructure. But Elastic Compute Cloud is a web service that provides secure, resizable compute capacity in the cloud. It is designed to make web-scale cloud computing easier for developers. And the idea is they have different types of EC2 instances. So you can create a virtual machine that has a bunch of memory or a little bit of memory, or a virtual machine that has a really large hard drive or a small hard drive, or more cores or less cores. You basically get to configure how fast and how capable is the machine that you provision. And so this is where I will be running my API. So Node is going to be running on EC2. That's kind of our back end. And then this elastic load balancer. So this allows you to balance traffic between multiple EC2 instances. And the idea is when you first deploy your app, you're probably only going to have one EC2 instance because you don't really, maybe you don't know how many users you're going to have. You just need a basic backend to use for your app. But let's say in the future you start to get more and more users and you need to scale that. The load balancer sits in front of the EC2 instance and actually allows you to balance the load between multiple instances. So you could have that same Node app running on several different virtual machines, and this load balancer, when the request comes in, decides which instance to send it to. So
I have a question.
Yes, go for it.
Do you have to have all of the EC2 spun up already, or can the load balancer spin up a clone or something for you?
My understanding right now is they already have to be running.
Okay.
Yeah, I'm sure there's something in there that will let you do that. Basically, like a dynamic scaling, bringing things out versus bringing them. What I've seen in the configuration here is you have to have all your EC2 instances up and running. All your services need to be running, and they all have to be essentially running the service on the same port, and it decides where to send them.
Gotcha. Thank you.
So these little snippets I have in there are directly from Amazon, and I'll share out this slide deck. All of these links go out to Amazon. You can read their docs. Chat.
Do you know, generally how many users per request you get to before you should scale that based on?
No idea. And it depends on every app. Node itself is a single running process that, we all know this. The way it's designed is it's not multi-threaded. If you design your app in the right way and you don't have any long-running functions or like long-running events, Node itself is still pretty scalable to like thousands of requests.
I think it probably depends on what kind of latency is acceptable in that situation. Because since like the loop in Node will just queue up shit and like wait to, at some point that's going to get to a second, 2 seconds, 3 seconds, 4 seconds. And so it's how responsive you need that to be.
And this load balancer will actually handles that for you. So it sees these requests coming in, and if like 3 simultaneous requests come in, instead of sending them all to the same server, it would send them each to a separate server if you had 3 instances up. So that way you're actually, for each of those users, it seems almost instantaneous because they're getting basically their own server to talk to.
Do you know under the hood, are they looking at the actual loads of these machines to decide it, or is it just random?
Probably not the load of the machines itself, the load of the incoming requests. So I'll read you what they have here directly from Amazon. Elastic load balancing automatically distributes incoming application traffic across multiple Amazon EC2 instances. It enables you to achieve fault tolerance in your applications. That's another thing. So like if for whatever reason one of your node processes crash and that EC2 thing goes down, if you have other ones up and running, your app is still up and running. Like you don't have any downtime. Seamlessly providing the required amount of load balancing capacity needed to route application traffic. So,
Sarah had a question.
Oh yeah, go for it.
Well, Sarah, have you ever done something to simulate traffic to your website?
It's totally, like there are tons of tools that will let you do that.
What about you?
Yeah, like I honestly haven't needed to.
Yeah.
So, but if the time comes, then you definitely want to do that. Like you want to see like how much load can I handle? Maybe how many instances do I actually need to handle that kind of traffic?
I was just reading about this a little bit over the weekend, and in addition to like load testing, you can stress test to see where it breaks, and then the new type of that test that makes a lot of sense. It never occurred to me is spike testing. And it was like, how responsive is it if you go to maximum load immediately?
It's not like a gradual build
Yeah.
up. So these two services work in conjunction. Now you could use EC2 by itself without the load balancer, right? That's just like spinning up a machine in the cloud, and that could host your Node API. But for this architecture, these two work together. The load balancer sits in front of EC2. So this is all about like the API, like backend stuff. And I didn't mention this, but this is really for a decoupled deployment, right? Like you have your API running on EC2. It's just a JSON API. It doesn't do any server-side rendering or anything like that. And then our front end is just static files. It could be a single page application or something like that. And our front end is stored on S3. So S3 is Amazon's simple storage service. It is a static file storage / static file server. So like by default, it will just let you store files there, but you can actually configure it to be a web server and actually serve up the static files that are in there. So directly from Amazon, Amazon Simple Storage Service is object storage with a simple web service interface and store to store and retrieve any amount of data from anywhere on the web. It is designed to deliver 99.99999% durability and scale past trillions of objects worldwide. But the idea is this is where all of our static files go. So our front-end code that does not require a backend, they're just JavaScript, CSS, HTML files, these will be stored on Amazon S3. Now again, S3 could be used totally by itself and you can host a website there. But for our cases, I'm going to be putting it in front of Cloudfront. So Cloudfront is Amazon's service for content delivery. Amazon Cloudfront is a global content delivery network that accelerates delivery of your websites, APIs, video content, or other web assets. Now the idea is Cloudfront automatically handles caching your site across the world. So when you create a Cloudfront distribution, you can actually tell it where you want your edge servers to be. And the lowest, cheapest one is to have a server in, I think it's US, Canada, and Europe. But essentially, Cloudfront has a worldwide network of servers all over the place. And when you set your site up with Cloudfront, they actually make copies of your static assets and put them on all these servers around the world. So no matter where that request is coming from, Cloudfront automatically it automatically chooses the server closest to the person making the request. So if you're in Europe, you'll actually get the front end in a much shorter time instead of having to wait for that request to go all the way to the US. And the idea is this Cloudfront thing is going to be sitting in front of Amazon S3. So whenever a request comes into Cloudfront, if it hasn't seen that request before, it it retrieves it from the S3 bucket, but then every subsequent request goes from the cached version of CloudFront. So by using CloudFront, you're essentially, like, you're creating, your front end now becomes a CDN, and it can be served blazingly fast. Like, it's going to be cached all over the world, and the next time any sort of static files are requested, they'll be served from a cache server.
The other advantage to CloudFront is that it's a lot cheaper than S3 requests are. So I went to a talk once by somebody who did a Super Bowl, an app that was advertised on the Super Bowl. It had a mega spike in traffic, and what was really cool about it is that the static assets were all served by CloudFront, and then even the app parts were really static apps with like a cron job, syncing them up like every couple of seconds.
Like static JSON or something?
Yeah, exactly. And he was able to handle like millions of hits over like an hour for like a couple $100.
Wow.
And
Like export his API as JSON files.
It was something where users could upload a picture and then it would like put something over the picture and then show it on the page, but there was no actual application. It would put it in an S3 thing, and then every like 5 seconds, 10 seconds or something, a cron job would rebuild the static page with all of the new stuff.
It's the kernel style.
But with both of these things, that's kind of the idea. Like, we're putting something in front of the actual application to manage multiple requests that are coming in. So with that, I have a
One question around
beautiful diagram. Go for it.
Did you figure out cache busting on it?
Yeah, totally. So that's one of the issues that you will run into. Like, when you deploy your app, like you let's say you've updated your front end code and you need to redeploy it, your code is still cached all over the world. So how you need to tell CloudFront, hey, when a request comes in, you should get the latest from S3 instead of serving the cache version. So in the AWS console, you have a place where you can, it's called invalidate a distribution. You basically say, every new request, you can set specific files, but you can also do like /star. So basically remove everything from the cache. When a new request comes in, get the latest file from S3.
Just do the admin panel.
Yeah, so you can do that through the admin panel. They also have, like, you can, they allow you to do like query string busting. So like if you're updating a JavaScript file or a CSS file, in your index.html, if you put like a query version on there, that is considered a different file, so it actually won't come from the cache. So there's multiple ways to get around it. Invalidating a distribution actually does cost money, just because they have to do the work of going out to all those cache servers, removing the files, and like it takes work on their part. So let's do some quick checks for understanding. What is EC2? Someone tell me, what is EC2? Roberto.
EC2 is a service by Amazon that allows you to spin up virtual machines, however big you want them.
Totally. And who can tell me what a load balancer is? Kyle.
Something that dynamically routes, it's an Amazon service, or no, a load balancer is something that dynamically distributes incoming requests to different servers.
Beautiful. And you can see that kind of drawn in this image here. Who can tell me what S3 is? Kim.
A simple storage service, and it's where you save and store your static files.
Yeah, absolutely. I didn't mention it earlier, but like an S3 bucket is like synonymous with a static host on Surge or a static host on Firebase. It literally is, you just put static files there and then they can be served up. Alrighty, who can tell me what is Cloudfront? Chad?
A CDN network.
It's also a PIN number. The N stands for network.
Oh, you're right.
Wait, what?
Content delivery network.
Content delivery.
Sorry.
No worries, but yeah, that's exactly what it is. Like, and like the word content delivery network is kind of loaded, but a content delivery network literally means there are servers scattered around the world. When requests come in, it smartly chooses what server they should be served from. So this little diagram here is like really what's happening with this architecture. So the idea is when you're visiting the website in your browser, you actually are being served from CloudFront. Like, you're getting your static assets from there. So I actually have mine on subdomains. So this is something like client.myapp.com. And when your browser makes that request goes out to CloudFront. Cloudfront then decides what's the closest edge server. So like, what is your IP address? What's the nearest thing? What's going to be the fastest thing to serve? It then decides to serve you from that server. That server, if it has a cached version of the page, will then immediately return it. If it doesn't have a cached version of the page, it actually goes to the S3 bucket, grabs the file, caches it on its own server, and then sends that request back to the front end. But the idea is, like, when you're actually using this app in the browser, you're using the static files that were served from here. Now, all API requests that go out, so like anything that's going to be requesting JSON data, that's actually what's going to be going to the load balancer. So let's say this page loads, and then we want to get an array of books. So it would make the request against api.myapp.com. That request goes to the load balancer. The load balancer decides which EC2 instance to send the request to, and then the request goes to the EC2 instance. Now, in this diagram, I have one database. Basically, no matter the instance, they're all talking to the same database. This could actually get more complex if you do things like sharding or actually like a distributed database distribution, where, again, it would kind of look like this. You have an entry point into the database, which then decides which other one to grab it from. But for my cases, I actually haven't worked with a distributed database yet. I just have a single instance, and then my instances talk to that database. But the idea is every request coming into this load balancer will dynamically decide which EC2 instance it should go to. And because they're all talking to the same database, there's no caching issues or anything like that. It's all the same source of truth. Like, no matter which server this node app is running on, you're still talking to the same data. And this pretty much assumes a RESTful API. Like, it's not dependent on state, because if you had shared state, it would get much more complicated. But if you have a pure REST API where you're just sending requests and responses, nothing being stored for sessions or anything like that, this works perfectly fine. But yeah, this is the architecture, and quick stretch. Reach into the sky, close your eyes. Cool. Questions about this diagram? Chad?
I noticed on your website yours / is actually backslash. Is that something we do when we're on Amazon instead?
No, that was an issue with this. So let's change that. Cool.
Just want you to know I'm
Totally. Cool. But this is it. And like for like once this deployment is set up, all your requests are going through Cloudfront and load balancer. Like at this point, you're no longer really even worrying about like the intricate details. It's like what the web browser really has access to are these two things, and then those forward the requests on their behalf.
I have one more question about.
Yeah.
So, are you going to talk about pricing at all, or?
No, I definitely will show.
I'm just curious which of these are free, or which ones cost, or.
Yeah. So if you haven't signed up on AWS before, you get a 12-month free trial. All of these things can be used in the free tier. So, but I will find the Amazon Web Services price calculator, and with that you can say, I want a load balancer. I'm going to have 3 EC2 instances. They're going to be micro with this much RAM. It'll tell you how much it potentially will cost.
I've done it before, but I don't even know what's in there.
But so for mine, I'm actually running it from the G School one. So I can't really break it down because they do have some other stuff that increases the costs. Let's see. Yeah, so we're halfway into the month and they've been charged $97. So total they're gonna be charged like $200. But like I said, they have a lot of other stuff running on here. It's not just my services. Though I think I have a majority of the services on here. Yeah. Cool, but this is it. And this really is like modern application architecture. The idea of being able to scale to a lot of users. Because like these EC2 instances right here, like you can put any number of instances on there. Like you all of a sudden, like you got on the front page of Reddit and you're getting 1,000 more hits, just spin up a new instance and now you're handling that traffic. Yeah, totally. So, wonderful. Who can give me a few sentence summary of all the things that I just talked about? Describe the role each thing plays in scalable deployment. Actually, maybe you can just like walk through this diagram.
Try.
Lana, go for it.
So EC2 works with a load balancer to run your API. You use that for running your API and distributing requests to it if you have a lot of requests coming in. Cloudfront works with an S3 bucket, which is a static server, and Cloudfront is a CDN that sits in front of the static server to host static files, which would be your client.
Yeah, that's good. Awesome. Sweet. Any final questions before I like start digging into this and like showing the console and how to do this stuff? Sweet. Yeah, so provision and Amazon SSL certificate. I think I'll show that really quick because it's like really easy. But the idea is for these services that I set up, you can actually just tell it to use the SSL certificate that was already provisioned, and then you just get SSL by default. So my mastery.galvanize.network app, this is using that architecture that I just showed you, but you'll notice it is running under HTTPS, so all requests are secure. This is the Amazon Web Services dashboard. When you log in for the first time, you probably won't see this. I think they changed it so that it's like more user-friendly, and it's like, hey.
This is a million times better than it was like 2 months ago.
But this is like because I've clicked on it a lot, but it will show you like if you're interested in this, click here. But now these are like all of the services available. Particularly we're interested in EC2 and then also Cloudfront for the front end. I also threw Route 53 in there just because that's how you would set up domains if you're pointing a custom domain at it. In my case, my custom domain is mastery.galvanize.network.
Is that something you buy through Route 53 or?
So I purchased all my domains on Namecheap, and then you can actually point your DNS there.
Did you actually transfer to Route 53, or did you just point?
No, I'm still using Namecheap DNS, and I just have a thing set up in Route 53. I'm gonna log into Namecheap and then show you all my domains and stuff.
Wow.
Not the
It's
longest.
just CJ rules 3 times over.
You have to remember how many times to put it in.
Look at all my domains. You know anybody with that many domains? Okay.
I've got like 50 in my panel.
So is it from like
about 3 of them that are active.
from like consulting or?
No, I just have this problem.
I have a problem too. Like some of these are
It's
unused.
one of the few things you can own uniquely in the whole world.
Yeah.
No
Wait,
one
what's
else
your
can
favorite
own it.
one? What's the most unique?
I used to
favorite
own what's wrong with longdomainnames.com. I recently canceled that.
Oh man,
I'm giving that one up in case you want to snag it, guys.
I just did all my tax prep shit and had to go through all the receipts for the renewals of these
Yeah.
domains that I've had for like years and years, like scastheNewRock.com.
Right? I'm going to launch something on this. That's maybe. I'll do it by then.
Audio Rogue.
Sweet. So this is my domain provider. Wherever you get your domains, you'll have like DNS settings. And for me, this is the settings for galvanize.network. I have a subdomain mastery.galvanize.network. So when we're looking at this diagram, that'd be like client.myapp.com. This is my front end. And in my DNS settings, I actually have mastery pointed to this Cloudfront distribution that I created. So when you create a Cloudfront distribution, it will give you a domain that you can set up as your CNAME. And then my backend load balancer is mastery-api.galvanize.network, and that is pointing at the domain for that load balancer that I created. So in Amazon Web Console, probably the first thing you would do is create an S3 bucket. So if you go into S3, you can create a bucket here. And we can actually look at my mastery.galvanize.network one. It's an index file, static. I'm using Webpack for this app, so these are all like the static built assets. But everything in here is just a static file. This bucket is configured as a as a static file server. So in your settings, you can go into static web hosting. Now, there's a lot involved in all that, like setting up an S3 bucket for front-end hosting, like setting up Cloudfront. Like there are a lot of steps that would be like a really, really long blog post. But I hope that I'm giving you the tools you need to figure those things out on your own. Like yeah, it would take a lot of time to really like put every single step in here. But the idea is I've set up this S3 bucket to serve the static site. So actually, if I visit this URL, we actually still get to the website, but this is the URL according to S3. So in this case, if we look at my my diagram, I am just going from my client directly through the S3 bucket. Like I'm going around all of this caching because of this URL here. But that's the idea. Create an S3 bucket, set it up for serving your files from a static file server, and then you're ready to set up CloudFront. So now that that can be served as static files, you can go create a CloudFront distribution. So if you click on CloudFront, you could create a distribution. I do a web distribution. In here you can put the origin domain name. So this nicely brings in all of your
Route 53 stuff?
well, not Route 53, all of the like buckets or balancers that you've already created.
Gotcha.
But I have found, like, so there's that bucket that's actually being served from, but this is not how I set it up. I actually, instead of putting that, the origin domain name I put was the static file server. So grab that domain. This is the origin. The origin path is just / meaning like where am I going to be requesting files from. Then you can set up your caching behavior. So I always do, I do redirect HTTP to HTTPS. So that way nothing can go over HTTP. If they try, it will automatically be redirected. You can say what methods you allow. The more methods you allow, like I think probably the more it will cost potentially because there's more things that have to be cached. You can set up if headers need to be forwarded if you need to. And you can also do right here, query string forwarding and caching. So by default, it doesn't cache things based on the query string. That was the thing I was talking about, where you throw the question mark on like your CSS file or something like that, put some version number after that, and then the browser thinks it's a new file, so it requests it. But you have to actually set that up. By default, it's not gonna do that for you.
Which one is the option for that?
Forward all, cache based on all. So you could also do a whitelist, meaning only forward the query string forward files with this name. But if you do all, then it caches all query strings. Yeah, that looks good here. And then on price class, you can set up your edge location. So default, it has best performance. That's going to be basically all around the world. I always choose US, Canada, and Europe just because I don't really know anybody in Asia using my apps. So
Racist.
I'm not.
Yeah.
But your
That's
architecture.
what you would say.
Your architecture is racist. But when I'm setting the price class here, that's actually saying like where these edge servers in this diagram are going to be in the world. And then here is where you can set up your SSL certificate. So on mine, click not custom, custom, and then Amazon also has like a certificate manager. Once you create it, you can access it from inside of here. So these are all my SSL certificates. I have like a wildcard star.galvanize.network. So I could create client.galvanize.network, API.galvanize.network, whatever, but I could use that certificate and it would be able to be served over SSL.
So you can create them for free in the ACM,
Mm-hmm.
and you can use them for free in CloudFront?
In CloudFront and in Load Balancer.
So if you don't have any certificates, do you create your first one by clicking on
I would create it before you even go into distribution settings. So yeah, that's fine. I'll get rid of that. But if you go over here, go to Certificate Manager, and then say Request a Certificate, your domain name, so cjiscool.com, or like star.that. The only thing you should be sure to set up is email forwarding, because Amazon will send a email to the to like admin@cjiscool.com, and then in that email you say I approve, I own this domain, and then it actually creates a certificate for you. So in my DNS settings on Namecheap, I have a wildcard redirect set up for my email. So yeah, so all emails that come into anything at galvanize.network get forwarded to my email address. So that way when Amazon Web Services sends that email, it shows up in my inbox, and I can say, yes, I approve, this is a thing. And then once it's approved, it will show up in this list as issued.
It's actually not a Amazon thing. That's like any certificate authority will do that in order to verify that like I can't get a dteach.xyz certificate and then screw CJ over by like revoking it last second. That everything's like, do not go here, CJ is a killer.
So Yeah, but once a certificate is issued and listed here, then you'll be able to select it when you're creating your distribution. And then it just works. It's like the easiest way to set up an SSL certificate. You don't have to do any like provisionings. You don't have to mess with the EC2 server or anything like that. Yeah, I jumped out of the creating CloudFront, but that's basically it. Like you point it at some origin. In this case, it's an S3 bucket. You give it its caching behavior, and then once you've created it, it will give you a domain name. So these are all the different CloudFront distributions that I have. Each one is at a different CloudFront domain name. But this domain name is what you would use in your DNS provider to point a specific, like a subdomain at that distribution. Yeah, so that covers pretty much the front end portion of this distribution. Now for the back end. So in here, if you go into EC2, we can create a new EC2 instance. So when you're creating an EC2 instance, you get to choose what operating system it was running on it, and then after you'll be able to choose all the settings like how big is the hard drive, how much RAM, how many CPU cores. I prefer Ubuntu because it's what I know, but you could also use a Windows server if you wanted to. But you select your the operating system that will be running, and then you choose your instance type. So all of mine are actually T2 micros, which is if you're on the free tier, it's totally free to run. But it only has one virtual CPU and 1 GB of memory. But for the things that I've been running, that's all it needs. I haven't noticed any slowdowns or anything like that.
What is it called again?
Which one?
Teaching instance? What do you, like?
I'll start from the beginning. Here, click on EC2.
Yep, EC2. You choose Ubuntu.
Yes, launch instance.
Type.
Yeah. So and then you choose your operating system. This is instance type. Quick break.
Because he's on the free tier, he's using T2 micro.
T2 micro.
Oh, yeah, sorry, T2 micro. In the UI, there's that little green thing. It's like micro instances are eligible for the AWS free usage tier. For the first 12 months following, you get up to 750 hours of micro instances each month.
You only need to go out if you have like scaling to do.
And like I have a general purpose T2 micro that I just always keep forgetting to turn off. I get charged like 3 cents a month for it.
Yeah, it's super cheap. I'll show the.
Maybe 5 years before it accumulates enough time.
Yeah.
Ironically, sometimes nanos feel like they're more expensive than micros.
I've done T2 micro. I did have a large instance for a while that like I barely used it all, but it ended up costing like $20 or $30. But you'll notice in this chart, like the bigger you go, the more virtual CPUs you have, and the more RAM. Also, there's a column for like network performance. Like if you really care, like you can make sure this is like ultra high performing, huge hard drive, tons of RAM. Like you can be very specific about your instance.
What is EBS in the instance storage? EBS only?
Elastic.
You can click the
Elastic Beanstalk. That's what it sounds like. Local instance store volumes that are available to the instance. The data and instance store is not permanent. It persists only during the lifetime of the instance.
Okay, so Beanstalk is storage.
Oh.
Oh, Elastic Beanstalk is like a bunch of different services all mashed together, and it'll scale it automatically for you.
It's like Heroku.
Yeah,
But
it's their version of Heroku. It's expensive as shit, though.
I don't think this stands for that because it might actually be a regular hard drive versus an SSD.
I think the E stands for ephemeral. And then I forget what the B and S is for. But S is storage, so ephemeral bullshit.
Binary storage?
I think what it means is it's not going to be as performant as like a solid state drive or something like that.
Okay.
So you can configure your instance details. Honestly, you can leave all the defaults and everything is just fine. You might want to configure like how big your hard drive is. My instances are just running a Node app. They don't really need that much space. So I just leave it as 8 gigs.
See, you store all that stuff in the database anyway, right?
Exactly, yeah. So like all the data store is on the database. So and then even if you were doing file uploads or something like that, it would probably be to S3. I would never use the instance for file storage. You can tag it. So in terms of security group, this usually I create a brand new security group for every instance, but I would call this cjiscool.com just so I know when I'm looking at the security group what it's related to. But the security group allows you to open up ports on the server. So by default, only port 22 is accessible because port 22 is SSH. But if you're serving up your app, you probably want to add port 80 or like port 3000.
TCP rule, you can go to that.
So you could choose like HTTP and that'll default to 80. But in my case, I have a Node app, it defaults to port 3000, so I could do that right there. And with that, 3000, and what that does is opens port 3000 to the world. So now external requests on port 3000 can
So
come
you
into
don't
this.
have to do environment port switching?
No, yeah, so you don't have to get that complex. Like I do, like I set up Nginx. You don't have to though, because if that's literally the only port thing. When we configure the load balancer, you just tell it to go to port 3000 and you don't even have to have port 80 redirects or anything like that. Because the load balancer runs on port 80, so to the outside world, they don't even need to know what the internal port is. So you would set up some custom rules, review it, and launch it. I'm not going to launch this one.
The other thing that might be important is that when you set up port 3000 there, you don't want to sleeve the IP address at 0000. You actually configure it to be only allowed access in from the balancer, load balancer.
Exactly, because the load balancer should be the only thing that can make that request, because if we look at this diagram, this is the only thing that needs access to port 3000 on each of these instances. So once you've configured your instance, if it's the first time, it'll probably ask you to generate like a PIM certificate. Essentially, that is how you're going to be able to SSH into that machine. So once the instance is up, make sure you have that file saved on your machine somewhere, and don't lose that file, because that's the only way you're ever going to be able to SSH into that instance. But once you have it, you can SSH in, and here we are. So this is the mastery.galvanize.network EC2 instance running in the cloud. So yeah, and in here, this is just like server management. Like I get cloned down the repo. I am using Forever to manage my processes. So Forever is a command line tool that lets you start up a Node app, and then if it ever crashes or something like that, Forever will automatically restart it. So I do have Forever running here, running the Node app on port 3000. And then to configure the load balancer, you go into EC2, create a new load balancer. I have not messed around with application load balancer yet. That very much seems like it's for like microservices. You can actually point it at multiple EC2 instances, but for specific API endpoints. I haven't messed around with it. I just use a classic load balancer. But the idea is any request coming in, doesn't matter what it is, will just be balanced between the services. With this, each service could be some particular part of the API instead of the whole thing. So create a load balancer. In this case, the load balancer port, I will set up HTTP and then also do HTTPS. But the idea is it should stay 80 and 43 over here, but over here is the port that it should be requesting on your instance. So in our case, because I have a Node app running, the instance port of the load balancer is port 3000. And this is a long break, and I'm pretty much done, I guess. I could be talking all day. So this creates the load balancer and tells it when a request comes into this load balancer, it should send that request to port 3000 on any of the EC2 instances. So then you assign, we'll give it a name. I would probably create a new security group. In this case, only 80 and 443. Here is where you can choose the SSL certificate for the load balancer. So in this case, I can say choose an existing certificate, and then I can choose that certificate from the dropdown, just like you did with Cloudfront. And then your health check is basically a port that the load balancer hits to see if your EC2 instance is still up and running. So it needs to know, is it up and running so that I can send requests to it. if you notice on here, I have this service called ping. It's literally just an HTTP server service running on port 8080. So that way, when the load balancer asks to see if the server is up, as long as that's going, it believes that the server is up. But this is basically your health check. And then you can add instances. So here you have access to all of the different instances you created before. So I would go in and choose that EC2 instance that you had created. And then create it. Once it's created, you can just use it. So, like if you look at but without setting up domains and stuff like that. So I could literally go to this CloudFront URL, and as long as everything else was set up in the same way, I get access to the website. The next step is to put the nice, clean domain in front of it, but that just requires domain configuration. Now, this was a lot. I mean, obviously going through AWS, like there's so many settings in there that you probably won't be able to remember. But Amazon is full of all kinds of documentation. I won't say they're the best in the world. They're very detailed. There's a lot of them, but yeah. And last thing, let's look at the AWS price calculator.
So there's two types of documentation you're gonna need. You're gonna need like the actual using the services. You're gonna need like actual configuration of the systems themselves. For this configuration of systems, you don't need Amazon. It's just any Linux guide will help you out. DigitalOcean has really good ones. Even though they're Amazon, they're really good to use. But for the actual like, what buttons do you click on EC2? You have to go through Amazon for that documentation.
What do you use to host your databases?
Oh yeah, interesting thing, it could literally be anything. So for this, I'm using a Mongo database on MongoLab. But that's just configured as like an environment variable on here. MongoLab, I've allowed access from this EC2 server. But Amazon does have their own, they have RDS, Relational Database Service, so you could host your database on here as well. I believe they have MySQL, Postgres, and potentially Microsoft SQL service. Yeah, MariaDB and Oracle. You choose your DB on here, you can set up all your settings and stuff like that.
They only do relational?
They only do relational there, but then they also have DynamoDB, which is like their NoSQL database. I actually haven't messed around with it much, but they don't have like Mongo hosted as a service or anything like that. Last thing to leave you with is this price calculator. Yeah, here it is. So you have all these things up and running. You want to figure out how much it's going to cost to run them. You can go in here and estimate the bill. So I can add an EC2 instance. So you give it a description. One instance, 100%. Let's say at 100% usage. Like I have people using it all day, all night. And then I'm doing like a T1 micro. That's going to cost $15 a month. If I say like, oh, well, people only use it during the day, like 9 to 5, I don't know, what's that, like 40% of the month? Then it's like $6 to run the instance. So that's for the instance. You can also go in here and then choose like, is it CloudFront? Monthly volume in terms of gigabytes. Like for mine, it's just static assets. It's like 20, 30 kilobytes. So like less, it's like, even if it was 1 gigabyte a month, yeah, average object size, like 10 kilobytes, if that. They're all over HTTPS. And let's say I do like 4 invalidation requests. So an invalidation was what I was talking about earlier, where you want to invalidate the cache. Let's say like 90% of my traffic is from Canada and 10%, 90 from the US and 10% from Canada, and I think yeah, 1. $600? What? No way.
Oh, it's all for that.
Oh, custom. Yeah. So no, that shouldn't be there. I think that's just referring to something else. So yeah, estimated is negative $6 if you're on the free plan.
This is how people are
They're like,
making
every time
money.
you try to save money, something happens and bam, it all drains out.
But like they are super cheap, and like I mean none of us are like running startups with like thousands of users, so like you you could be running this architecture for like under $10 a month. Cool. Any final questions, comments, concerns?
So one of the really cool things that you can actually set up your you can set up your load balancers to bring up, to like run scripts to bring down and bring up instances.
Okay, that's what Kyle was talking about.
You can
Yeah.
start with one at a time and have it like bring up unlimited numbers of them, and like that's where you can get into trouble usually with money when like you don't set an upper limit, and next thing you know you have like 10,000 instances running. And you can also set it based upon CPU, network, data transfer, hard drive space, all sorts of crazy stuff.
Yeah, so this is the settings for the Galvanized Mastery load balancer. I actually only have it's only pointed at one instance. Like I don't need multiple instances for this. So that's the instance it's pointing at. It is in service. Oh, is that right? No, that. That doesn't seem right. Doesn't matter.
A really popular type of load balancer to use in like industry is that first type.
Oh, you're right. Yes, that's the one I was looking at. But same thing. There's only one instance. Because API observe is observe.gt.xyz, and this is actually running under the same architecture. But different instances, different.
Yeah. So, CJ, if you bring up your map,
My
network map, or
network. Oh, my diagram.
LG map. So a really popular thing in new microservices is to have another system over here that monitors all these instances, and if they like for some reason go down, or if you need more, it handles bringing more of them up. And this is what Netflix does. So they can have a Chaos Monkey, which basically comes in here and doesn't just like turn off the software in the like it wouldn't go in like say like kill all node processes because forever would restart that. It goes in there and says, hey, what happens if I just like issue the shutdown command to like this entire node? And then like 5 seconds later, I issue a shutdown command on this entire node. And then eventually it'll get to all of them and then CJ will be screwed. So you might have another server that sits there and watches these, and when they get shut down, it spawns another one up. And then tells the load balancer, there's another one right here.
So Chaos Monkey was a tool written by Netflix, right?
It's a tool written by Netflix for Netflix, but it's open source. So we could all run it and destroy all of our software.
But the idea.
I think we're over time and we're it's not kind of
Oh, okay. But the Chaos Monkey is super cool because it wreaks havoc on your infrastructure to see if you can handle it. So like Netflix does it because they